Hey, welcome everyone. I'm Paul Deffenbaugh. I'm the editorial director at Metal Architecture Magazine, and we're glad you've joined us today. We're doing today's webinar on metal roof systems, design and installation considerations, and it's being presented by AEP Span. This webinar is part of the Metal Architecture webinar series. Jeffrey Medeiros is the speaker today. He's an expert in this field, so he's got a ton of material, and you're going to want to ask lots of questions. We'll break for questions a couple of times during the presentation, as well as answer them at the end. And I always encourage people to submit their questions on the panel you see there when you think of it. Don't wait till the break to ask them. That gives us a chance to review them and make sure that we get appropriate answers. And also, it's easier to think about when you're thinking about it rather than holding. Of course, the most common question we get is for information about AIA credits and certificates. So listen up. For those looking for certificates and AIA credit, they'll be handled automatically. Please allow 7 business days for everything to process. That information that I just said there is going to be repeated in an email that you're going to get 24 hours after the end of this webinar. That email is also going to include links to more information, ways to ask technical questions. You can review the webinar if you want, and you'll be able to download the slide pack with a link from that webinar. So now let me introduce our speaker. Jeffrey Medeiros is the architectural representative for AEP Span and a licensed contractor. He's been supporting architects in California for more than 10 years. He can spec write, assist in detail drawing, and aid in product selection or any aspect of the design build process from initial design to complete bid ready documents. Jeffrey's fluent in building code, bid laws, and contract code, and he provides architects with a full range of service from conception through bid. Jeffrey holds various degrees, including Law and Society from UC Santa Barbara, Japanese from the Waseda University in Tokyo, and he attended McGeorge School of Law in Sacramento. He's fluent in all types of roofing systems built up and torch applied, hot and cold process, restoration coatings such as silicones, urethanes, and acrylics, single ply roofing, and all forms of metal applications, including roof, wall, coping, and soffit, as well as flashing and trim. Jeffrey made the move to AEP Span about 4 years ago after spending years with a competitor, and he plans to stay on through retirement. That's good news. Jeff, why don't you take us away?
Good morning, good afternoon, good part of the day to wherever everybody is. We're going to go through this. If you've been with me before, sometimes I go off the slides, so you're going to want to make sure that you pay attention because usually when I do that, there's more good information coming. That being said, let's get started. Metal roof systems, design, and installation considerations. We're not going to the next slide. Hang on. There we go. Okay. This is the course number, which we have to show, of course. Moving on. This is one of the only slides I'm actually going to read. At the end of this program, participants will be able to list the advantages and disadvantages of architectural roofing versus industrial roofing, as well as the features of exposed fasteners and standing seam assemblies. State specification considerations related to all metal roof installation, discuss energy efficient features of metal roofing, and the environmental impact of metal roofs versus alternative roofing materials, and list the design and installation issues that help facilitate a successful metal roof solution. That being done, let's get on with the course. Okay, this course is going to begin with a discussion of the pros and cons of architectural roofing versus industrial roofing. We're going to follow that with an overview of exposed fastener roof systems versus standing seam roof assemblies. Spec considerations that are critical to a successful installation will also be reviewed, such as proper substrate, underlayment material selection, metal gauge coating, sealants, and so on. So let's start with the evaluation of the types of metal roofs. Architectural systems. The 2 major applications for metal roofing are architectural and industrial. An architectural roof system is specified for performance, life cycle costs, as well as aesthetic reasons. In the roof is often part of the overall architectural design. Non-structural metal roofing usually requires a solid substrate beneath it, such as plywood, a metal roof deck, or rigid insulation over a solid substrate. A low-slope industrial roof system, on the other hand, is selected more for its function, performance, when cost is the major factor of the project, along with feasibility. Structural metal roofing attaches directly to the secondary structural members and may not require any sort of solid support beneath it. Let's move on. This one I like to blow through pretty quick. Advantages and disadvantages, because I like to get on to this stuff and talk about it. Okay, exposed fastener roof systems. Exposed fastener panels, by definition, are number one, through fastened. They have fasteners that go through the metal. Number two, they're nestable. You can stack them one on top of another by moving the panel above to the left or to the right, and they can ship on pallets. And number three, they rely on laps and sealant for waterproofing. Doesn't matter what the profile is. It can be a sine wave, trapezoid panel, a box, a diamond, a V, whatever you want. Corrugated is all of the above. Exposed fasteners, again, through fastened, nestable, and laps and sealant. These have been considered the standard in metal building for over 50 years. Exposed fastener systems, also known as through fastened, provide an economical performance value option. They're durable, lightweight, available in any texture and color you can think of. They can be installed vertically, horizontally, used on roof, used on walls. These configurations can be fabbed in varying gauges that provide both high, negative, and positive load carrying capacities. Note that some types of these fastener profiles have been tested to provide diaphragm support. So, along with the favorable attributes, exposed fastener roof systems have certain drawbacks. An exposed fastener panel relies on a visible fastening device for connection to the desired substrate and requires a field applied sealant to improve the weather tightness of the assembly. Also, these panels are pinned at every attachment point, thus not allowing for thermal cycling. So I'm going to go off track on this a little bit. The good thing about corrugation is every single one of those corrugations acts as a tiny spring. If you take a piece of paper and you hold it flat on a piece of granite or a solid table, and you put your fingers at different points throughout either end and you push them together, that paper is going to flex at a different point every single time. Now, if you put a fold in that paper, it doesn't matter where you push on it, it's always going to flex on that fold. And that's what a corrugation is. It is a predefined point of flexation that helps to absorb that. Despite this, because they are through fastened, the top of the fastener head is going to catch a lot of the heat and it's going to transfer it down through, and over time you're going to get little holes and or openings, which I believe takes us to this slide. Over time, there we go. Over time, the expansion and contraction of the panels creates an elongated hole at the screw location. Again, it's a simple fix. Take out the existing and drive in with the next size up to 10, go to a 12, and so on. But just something to keep in mind when they're there. Typically, exposed fastener panels should only be used on shorter panel runs. Again, this is because of the thermal cycling. And they're not recommended for slopes less than 1 in 12. If you're in certain states or you follow IBC, code requires that corrugated is only used down to a 1 in 12 slope over conditioned space when relying on laps and sealant. You have to have sealant in there. If there's no laps and sealant or there's no soldering, it's 3 in 12. So in these cases, a standing seam roof is preferred. Okay, so what's a standing seam? Opposite of the through fastened, they are concealed fastener. So you may hear them called concealed fastener or standing seam, etc. They are also not nestable. If you have a 12-inch wide panel or a 16-inch wide panel, you can't fit another one inside. It's the same width. So these panels, when they ship, have to be flipped over upside down and stacked on top of one another with the flat sides facing opposite directions. They also typically do not rely on laps and sealant for waterproofing, but rather a standing seam / lay. Only exception to this is with a lapped panel. So pretty much the opposite of everything an exposed fastener is. Here's a couple different options. In the upper left, you see a male-female lock. In the middle on the top, you see a mechanically seamed panel with a 90-degree hem. On the upper right is a 180 seam. And then on the bottom, your traditional batten roofs, batten panels, which they're essentially just two 90-degree bends and they fit around a clip. So these type of panels don't have that waterproofing in between each adjacent panel. So the batten is what provides that protection. And because of that, they need a higher slope. So Designed with a tall seam to resist leaks, standing seam offers performance coupled with aesthetics. The increased usage of metal panels on steep slope roofs is also coming into play, rather than just low slope roofs. But many architects prefer not to see the exposed screws attaching the panel to the substrate. So also, the standing seam panel is one that the fasteners are hidden, so they're not going to thermally cycle like exposed fastener panels will as well. The clip, excuse me, is attached to a substrate and entraps the vertical panel legs, and the concealed fastener eliminates the elongation of the fastener penetrations due to thermal movement, typically because the panel is moving within a clip. Brings us to the next slide, excuse me. There's one-piece and two-piece clips. One-piece clips are typically used with snap-together metal roofs in male-female, and they entrap steel leg, and this is unlimited thermal movement. Two-piece clips, however, are typically used with mechanically seamed roofs, except for a T-seam or a bulb seam. These, though, the actual clip is rolled into that panel leg, and so the floating clips are required with plus or minus 1 inch of thermal movement, which is going to limit the overall length. I'll get into that in a little bit, but keep in mind there's one-piece versus two-piece clips that can be utilized. So bearing plates. Bearing plates are used when installing panels directly over rigid insulation to disperse the load of the clip from it compressing. So here's how you think about that. Rigid insulation ain't so rigid, right? If you're up there and you throw polyiso down, it has a compressive value of about 25 psi. That means if you step on it as a normal sized human being, you're going to put a dent in the ISO if you're not careful. So what do you need? Either A, an exterior jip like a Densdeck Prime, USJ Secure Rock, or in lieu, you can use a bearing plate. In layman's terms, it's a big snowshoe, right? The clip slides into that bearing plate, which is pre-perforated, and the fasteners run through both of them and under tension. Instead of the clip's small footprint sinking into the insulation and the fasteners losing tension, the bearing plate distributes that load like a snowshoe, and you're good to go. Continuous standing seam panels can be used for long runs, low slopes, but it's important to be aware of the limitations. So continuous standing seam panels at extra long lengths perform no differently than a properly installed lapped panel. Extra long panels are prone to installation damage and present greater installation challenges. So here's how I'd like to think about this. I know that everyone thinks that a long length panel might be the best way to go because no laps means no holes and it's going to be more strong and sturdy and waterproofed, right? Well, until you have to take into consideration the cost of what that is going to entail, which if continuous panels are required, you need to ensure with a quality supplier because a lot of manufacturers don't offer mobile roll formers operated by factory techs instead of the contractor, which is going to invalidate your warranty. UL follow-up services, machine certificates. So ask the metal manufacturer if that roll former is even certified. The other thing to take into consideration here is if you're going to use long length panels instead of a couple shorter ones, you're going to need to have certain things like crowd control. You're going to need to have an on-site crane, a spreader bar, which is incredibly expensive, one man or woman or person per 10-foot length of that panel. So all of a sudden your crane rental and your spreader bar at 150 grand plus paying 16 men or women or people to move a 150-foot long panel might not be the best way to go when you can do 3 50-foot lengths. Also make sure you don't twist the darn thing, which is why that spreader bar comes into play, because if you do, you're going to torque that panel and it's not going to be good and the entire panel's wasted. So certain things to keep in mind there. Available in the market are also non-structural metal roofing panels, which are designed to shed water and sloped applications over solid substrates, as well as structural metal panels, which don't need them. With limitations based on wind uplift and condensation control, metal roofing can be installed over wood, such as solid decking, plywood, nail-based insulation, or SIPS panels. And it can also be installed over steel substrates, including structural steel decking, both light gauge and structural secondary framing components, both in new construction and retrofits. So out of plane substrate, what does that look like? It looks like that. Make sure you select the proper substrate when roofing over. And if you have a poor substrate, make sure it's level before you put a panel over it, because the metal will follow the substrate. Underlayment. Underlayment is you have a couple different options, including felt paper, synthetics, mod bits, and so on. Choice of underlayment is going to depend on a lot of factors. I do like using a 40 mil peel and stick modified that's also going to be high temp. And the reason for high temp is under certain conditions, metal roofs can have extremely high temperatures under those metal panels, and asphalt impregnated paper can re-emulsify and leak down the sides of your building. So that's not a good look. Vapor retarders, we can get into this. This is very, very specific. Generally designed to be installed on the warm side of the insulation or directly underneath the metal panel. Again, 40 mil peel and stick is my favorite way to go. If you have questions in regards to this, feel free to reach out to me for your site specific and project specific conditions. All right, gauge. A change in gauge will affect both positive and negative load carrying capacities of the metal roofs. So due to the nature of an exposed fastener roof panel, a heavier gauge material is generally used to accommodate the requirements for positive loading only. With exposed fastener panels, 26, 24, and 22 gauge are industry standard. 20 and 18 are non-standard. It's quite durable there. When required for added durability or greater positive load carrying capacities, those can be used. But on the other hand, standing seam is generally 22 or 24, and we can sometimes go to 20 for certain projects. Although test data is sometimes limited, both exposed fastener and standing seam can be provided in aluminum, copper, stainless, or whatever metal you need to meet the specific design conditions. But again, test data may be more limited. Oh, we're on my first question. Any questions so far?
Thanks very much. Yeah, we do have a couple of questions, and a couple of people are asking about the limitations on slope for these various roof systems. In other words, how low can you go? I think, for batten seam, for standing seam, are there limitations? What are they?
Yes, so let's address that real quick. So let's first start with exposed fastener panels. Exposed fastener panels under IBC are limited to 3 and 12 without laps and sealant. Without, excuse me, a sealant within the elapse. They're limited to 1 and 12 over conditioned space with sealant in that lap. Anything below that is you're on your own, and that's typically used over non-conditioned space. In terms of standing seam, the traditional batten style panels that are, I mean, if you made an L with each of your thumbs and your pointer fingers and you held them on either side, that's what the panel looks like, right? It's just two 90-degree bends that have that batten seam. Those are typically limited to a 3/12 slope. Okay, a male-female interlocking panel, snap lock style, is limited either, depending on manufacturer, to 1 and 12 slope or to 2 and 12 slope. Again, this is manufacturer dependent. A mechanically seamed panel is generally, again, manufacturer dependent, limited to a 1/4 12 slope. Anything below 1/4 12 slope under IBC is required to be coal tar pitch. And if you want to get involved with that, we can have a discussion after the fact. I've got info on it. But mechanically seamed, 1/4 12, snap lock, 1 and 12, 2 and 12, batten style, 3 and 12.
Were you done? Sorry about that.
Yeah.
Let me ask one more quick question and move on. Is about sealants for exposed fasteners. About how frequently do field applied sealants need to be reapplied, and how hard is it, of course, and does the roof need to be taken apart, or can application be done without dismantling panels?
Got it. I'm going to get into that later. Very good question. There's exposed sealants and there's concealed sealants. When you do a lap in a corrugated panel, you use a concealed sealant, which is a non-exposed, and as long as they're not exposed to sunlight or UV, they're sticky forever. but
Um,
I'll touch on that.
okay, great. Let's continue on. We're getting some great questions, and I want to make sure we leave some room to get through all the material.
Metallic coatings, okay? Metal comes in from the coil manufacturer, and a coil is essentially a big roll of metal toilet paper, okay? It's 4 feet wide or just over 4 feet by however long this coil is. It's measured in tons, but I want you to think of it as a roll of metal toilet paper. It comes in, the first thing that happens to that metal is it gets coated. I like aluminum zinc, i.e. Galvalume, also known as Zincalume. Do you want tissues or do you want Kleenex, right? It's the same darn thing, different trade names. Tissues, Kleenex, Charmin, toilet paper, whatever. So it's a 55-45 aluminum to zinc by weight, okay, by weight. Again, trade names, Galvalume, Zincalume. If you hear that, that's what it's after. The aluminum component of the Zincalume provides the corrosion protection to the steel sheet along with the corrosion warranty, while the zinc component provides the sacrificial characteristic that protects the material edges and cuts. So oftentimes when we're talking about bare metal, we're talking about aluminum zinc coated metal, okay? So when used for low slope roofing, Zincalume coated sheets perform very well, lasting 30 years plus without corrosion failure. That's without paint, okay? That's without paint. Hot dip steel sheets are available bare, unpainted, with up to a 25-year warranty. And the product is also used as a substrate for a pre-painted sheet when you want a more decorative finish. So that's what I mean by this is metal comes in, it's coated in Zincalume before paint. So there's also zinc coated steel, which you often see as G90 or G60. Well, that's your galvanized, okay? Galvanized is not the same thing as Zincalume Galvalume. It's not warrantable. Therefore, don't run with it unless you have to, okay? Galvanized substrates are not warrantable. Zincalume is. Paint options for metal roofs, okay? We're gonna start and go up. Polyester, then SMP, then Kynar, right? SMP coatings are generally used on 26 gauge industrial products and pre-engineered building systems, and they have typically a 20-year warranty. Okay, polyester paint coatings are also in the industry for very economical paint systems that have decreased chalk and fade values, but they support that part of the market that is looking for an affordable alternative. Okay, so let's say you don't want those two. Let's go to Kynar. Kynar 500, Duratec 5000. I mean, all the same thing, okay? Most widely used in the architectural market, it's a paint system containing a minimum 70% fluoropolymer or Kynar resin. Chalk and fade qualities outperform polyester powder, urethane, silicones, acrylics, hands down. Kynar paints, this slide is actually out of date now, may be warranted for up to 40 years, not 30. So when you couple Kynar with a Zincalume Galvalume / substrate, the product is going to have exceptional color stability, chalk resistance, durability, abrasion resistance, and a substrate warranty. So even for severe corrosive environments where you'd say, hey, I should use aluminum. Well, maybe not. I'll get into the differences of steel and aluminum a little bit later. But steel, you can use an industry standard 1 mil Kynar based coating. You can do a high build primer or a top coat. So you can warranty a steel coated substrate with Zincalume Galvalume with a paint system over salt water for 20 years. Moving on. Okay, the 24 gauge base steel, that's your roll of toilet paper. Okay, it comes in. The next moving out on the top and the bottom is a Zincalume substrate. It's coated. That makes it all nice and durable, right? You can put that out there and it looks like bare metal even though it's not. Then you get a primer coat and a backer coat. The backer coats are typically SMPs or polyesters. Top coat is Kynar. I know that there's going to be a question asked, but Jeff, I want to do a shade structure where it's colors on both sides. Well, you can do that with Kynar on both sides. It's just a one-off order and you're going to pay for it. Okay, I'm going to blow through these pretty quickly. If you have questions or concerns on warranties, reach out. There's way too much info in here. No warranty is the same. They're very complex and convoluted. Make sure you check the warranty language, though. It's critical to examine and compare not just the length of the warranty, but the comprehensive and what it covers, the adhesion to the steel, is it color, fade, chalk, oxidation, is what's the remedy, is there a reset clause, and all kinds of stuff. Reach out to me on that. Sealants, here's the sealant question. Okay, sealants protect against moisture intrusion on the roof at the exposed panel flashing edges or lapse conditions. There's a couple different sealants used, okay? Non-curing butyl is typically tube applied. This type of sealant should be used in any areas on a metal roof that are subject to dynamic movement of the panel, i.e. a lap, including panel side laps, end laps, flashing attachments, and any other metal-to-metal connection. Not only does non-curing sealant protect against capillary action, it allows the panels and flashings to react thermally, expand and contract without compromising the integrity of the sealant. It's not going to dry out. It's not going to break down. It's not going to get decayed or destroyed, provided it's not exposed to sunlight. Extruded butyl tape. This is a tape that's available in rolls, usually up to about 50 feet long. They're used where long continuous beads of sealants are required in more sensitive areas such as valleys and ridge caps and eaves and so on. Again, it's butyl, so use it all in non-exposed applications because it will break down when exposed to sunlight. They're, in essence, the exact same thing as the non-curing butyl sealants we just talked about. They just come in tapes, and they're different thicknesses, widths, and lengths. Single component urethanes, tube applied. Any area of the roof that's exposed to sun. These are also used for metal connections to non-metal connections like masonry blocks, stucco walls, wood, and so on. They come in colors too. All right. Specifying for metal roof solutions. So let's review the specification considerations that help facilitate successful installation. Material quality and source. So testing. As a quality manufacturer can provide test data, I'll throw that out there. Wind uplift, ASTM, E1592, and air and water infiltration, 1680, 1646. Manufacturer qualifications, how's metal manufactured, what's the level of their experience, are they certified? We can go down a rabbit hole with this. So if you have questions on this, in the interest of time, reach out to me later and I can walk you through it. So there's also the installer side. Make sure you have a qualified installer with a level of experience. They're manufacturer improved and trained, and they've done X amount of installations within a certain distance of where your project's located, and they can bond this type of project because you don't want two guys in a truck that do painting one week, cabinets the next to install your metal roof. Okay, verify all the submittals. Again, we're going to cross over this quickly because it's pretty self-explanatory. The gauge, the testing, and so on, and then require stamped calcs for your project-specific conditions. So, energy content. This also changes, but let's explore real quickly for metal roofing, solar panels, environmental impact, and so on. To that end, various software programs are available to use, such as ISO 14K, environmental standards, Athena, Eco Calculator, and so on. But it's important to compare not only the life cycle sustainability of a product, but also its full range of environmental and social impact in order to choose the best solution. Again, this is a rabbit hole we can go down if you're following lead, or if you want to go on the different pedals and so on. I've got information on all of that. Reach out to me if you're interested, from lead to living building and so on. Some coatings, that can be an entire presentation on its own. Some coatings and finishes are available today, qualify as a quote-unquote cool roof product. What a cool roof product is they have infrared pigments incorporated into the paint. So they put magical little sprinkles into the paint that give it a higher reflectivity value, even in darker colors. So where you see a cool dark bronze or a cool matte black, that's what it's referring to. For instance, a roof with normal pigments may have like a I don't know, a .07 reflective value, but to improve it to a .32 with their pigments, right? So cool metal roofing has high solar reflectance values and emissivity values exceeding 80%. A cool metal roof will reflect the solar heat back into the atmosphere, lowering both the inside temps of the building, the surrounding environment, and thereby reducing the heat island effect, also the intake temps of HVAC. Additionally, the life expectancy of the roof is increased, less thermal cycling. So here's a couple colors and how to look at SRI and thermal emissions. Again, reach out if you need some help. Modular solar. A metal roof solution can incorporate PV, no problem. I prefer these, which, I can't mention manufacturers, huh? Reach out to me if you want some help on this. There's certain manufacturers that make these clamps. They'll clamp onto the standing seam, won't put any holes in the roof. You tighten that down, and then you can put a PV on top of it. So it kind of looks like this, right? Set those clamps in place, lay your subframe, and put the PV on top. Self-explanatory. Keep the similar metals apart. Clamp-on systems won't void a warranty, but you should note that it's not, damage from them isn't covered by, well, any manufacturer I know of. So follow the torque considerations very carefully. And that's what it looks like there. We're at another spot.
Hey, thanks, Jeffrey. We've got a lot of questions here about fasteners and especially exposed fasteners, and let me try to pull them all into one big question if I can. How long, are there any particular screw materials for exposed fasteners? And are there issues with galvanic action around the screws, such as with other materials like wood, pressure treated wood? And let me see if I can get another one here. And are there any issues with a through fastener mitigating the holes that could open up due to movement as a result of that? And I think that so everything you know about fasteners.
Okay, yeah, so exposed fastener roofs, I have to be careful how I handle this one because it's going to vary widely from manufacturer to manufacturer. What I'm going to say is whichever manufacturer you're specifying is I would follow their fastener recommendation to the T, because that's what all your IATMO and ICC and ER reports are going to come back with, right? So all their testing and values are done with a specific fastener. So I would use that as my point of reference, and it could be different across the board. Typically, exposed fasteners have a neoprene washer that when you drive it to the correct torque spec, it's going to compress just slightly, and it's going to isolate that fastener. Now, in terms of when a hole is created, so here's how you have to think of it, okay? You ever walked by a fence in your backyard or a neighbor's yard and there's nails sticking out? That's a result of everything moving, right? The actual fastener is heating and cooling. The wood is expanding and contracting, just like that. And over time, it backs that fastener out. You have to drive it back in, right? That's why some nails hold differently than screws and so on. Over time, the same thing happens to metal, because metal, just like wood, expands and contracts. And that fastener is going to get hot and it's going to get cold. So when it does that and everything's moving around, a little hole might be formed, right? Over years. And again, it may not, depending if it's on the cold side of the building. So what happens is technically it is a serviceable item, right? You're going to have to send someone up and go check fasteners, every year or two, or the older it gets, at least every year. Walk by them, check them out real quick, and if any fastener is not driven, drive it back in, and if there's a hole, pull the fastener out and put it in oversized. Solves the problem. So this takes place, generally speaking, I shouldn't say generally, a lot of the time, almost all the time, on conditioned spaces where there's a temperature difference, where the fastener and the metal panel are the same temperature as everything around it. It tends to happen a lot less. So again, on industrial applications, metal buildings, canopies, and so on, where there's not a conditioning space below, happens less, which is why those are typically used in that instance. Hopefully that
Thank you.
answers questions.
That was comprehensive, yes. Hey, let me do one real quick question. One of the audience members wants to know about any special considerations for curving standing seam panels.
I get into that later. Curving standing seam. Okay, real quickly, you can curve standing seam dependent on manufacturer and profile. I know certain panels cannot be, where others can be. Typically speaking, the mechanically seamed ones that are rolled into the clip have less of an ability to be curved as compared to like a batten style panel. Batten style panels, you can curve. So I want to say a 4-foot radius versus, you know, a 32-foot radius for a mechanically seamed panel. Typically speaking, snap lock style panels, male, female, you can't curve. So I can get into it with you later. There's a couple of things to take into consideration, but generally, batten seam, you can curve to quite tight radiuses, concave as well, concave and convex. A mechanical seam, you can curve on a much larger radius, and snap lock style panels don't do it. All righty, moving on.
Yeah, thank you.
Design and installation considerations. Let's talk about wind uplift, air and water infiltration, drag loads, and some details. I'm not sure if everyone hears that, but it just played a wind file. So if you hear wind, that was from my presentation. Wind is one of the essential design factors in roof. The non-continuous attachment of metal roofs makes them particularly susceptible to high wind, defined as the upward force exerted by wind traveling across a roof, right? Bad things can happen if not done correctly. So listed on this slide are some key factors. In the interest of time, where I'm going to move through them. I'm sure you're familiar with these. We can provide on-site calcs for these when you provide this information. Exposure, exposure B, C, D, so on. The smoother the terrain, the greater the wind load. Basic wind speed, building height, roof slope, internal pressure, they all come into play. Okay. Structural standing seam panels are tested under ASTM E1592. That is the, I want to say, standard test method for structural performance of sheet metal roof and, oh, it's right there on my slide. Of sheet metal roof and siding systems by uniform static air pressure difference. I was getting it right though. All standing seam metal roof panels should be tested under the UL 580 uplift test as well to meet minimum requirements in the industry. Additionally, the manufacturer should subscribe to the UL follow-up service because projects often require more stringent test results. Many standing seam panel manufacturers test their metal panels with other agencies other than UL, such as ASTM and FM. Okay, got to pay attention to this one. Ready? UL is pass-fail. Okay, did you pass? Did you fail? ASTM and FM testing takes that panel to failure. All right. So just because you got a 71% and your pass fail rate was a 70 doesn't mean it's the best panel around. ASTM, you know, takes that to failure. So maybe your grade was a 71 on that test and you passed, but you aren't that kid that got the 98, right? So by taking it to a failure point provides important data to develop accurate negative pressure information useful for determining the panel performance and clip spacing. That's where your ER reports come in. Your ICC and your IAPMO and so on, right? So pay attention to that. All right, air and water infiltration. In addition to wind, test for air and water infiltration. That's your ASTM E1680 for air and your 1646 for water. With proper sealant placement, exposed fastener panels can also provide adequate air and water infiltration control. And in addition, the standing seam roof panels that require mechanical seaming in the field and also require a panel-to-panel end lap due to a long length. Remember my example of 3 50-footers with 6 people and no crane, no control, and not having to monitor wind conditions for wind that might spin a 150-foot long panel versus a long length panel. Again, there's pros and cons to both. Maybe you want a whole length, but maybe you don't. The panel end lap test is tested under the ASTM 2140 as well. So that's where the panel-to-panel end lap is flooded with 6 inches of water, standing water, and then it has to hold for a period of 6 hours under pressure with no signs of leakage. So these tests are quite comprehensive. We're going to blow through this pretty quick. Again, keep in mind that UL reports do not hold the same value as ASTM. UL doesn't push to failure to pass-fail, while ASTM does push to failure. And the ASTM tests are generally what's put in the ER, independent third parties, compared to UL. So in terms of FM as well, talk to me offline. If you want an FM roof, you should have FM requirements in the insurance. Okay. This is what some of these reports look like. They use expand and contract with changes in temperature to take into account as well. The buckling of sheets, tearing at the seams, loosening or pulling through the fasteners are common failures. So the rate of expansion and contraction is going to differ with each metal on the table to the right. I believe this one's actually out of order. Should have been after this. Anyway, different metals move different ways, right? Okay, evaluation reports and approval reports look like this. It's going to give you a table to extrapolate everything out. You're going to have your gauge at the top. So if you look at the one on the right, you're going to say outward negative uniform load capacities of 20 and 22 gauge of whatever product. You're going to go over to your left under the substrate. You're going to find what you're going into. Are you going into metal? Are you going into wood or whatever, right? And then you go one to the right. What gauge of metal are you going into? And then you take your site-specific wind load requirements and you cross-reference that with the table, and you get what spacing you need. All right, details. There are 3 ways to accommodate for thermal movement. 1 at the low end of the panel, 2 at the high end, or 3, both. Low, high, or both. Typically, panels are pinned at the high end or upslope of the panel. To accommodate movement at the low end of the panel, the high end is pinned and fastened, and the low end is a floating eave, right? It can then expand and contract down slope. To accommodate movement at the high end of the panel, the low end is pinned at the structure, so conversely. And the high end floats to accommodate the thermal movement. This method requires exposed fasteners at the low end of the panel. They may be of aesthetic concern. The third method is to allow expansion and contraction at both the high and the low ends of the panel. This requires pinning somewhere in the middle of the panel for drag load, usually at a lap. This is generally done on long panel runs, i.e. where you have 70 foot plus in either direction, upslope and downslope, for 140, 150 foot long panel plus. This is done where the expansion and contraction is so great that it makes it difficult to allow for it to adjust at just one end, which reminds me why I put that slide there actually. So steel's going to move around 1/8 of an inch over a 10-foot stick, where aluminum's going to move 1/4 of an inch over a 10-foot stick. So when you have these long panel runs, your panels may be moving inches each day, right, as they thermally cycle. So that's where that movement in that clip of plus or minus 1 inch is going to come in on that 2-piece clip. So they can expand downslope 1 inch and upslope 1 inch, and you can hit those long lengths. So an example here, you have a roof. I don't care if it's a shed roof or it's got a ridge, right? Going to pin it up top. It's going to expand downslope at 75 feet. But wait, Jeff, I've got a huge shed and I need 150 foot length. I don't want to pay for a spreader bar. I don't want to pay for on-site roll forming because the truck can't bring in 150 foot panels. I don't want to pay for 1 guy per 10-foot stick. I don't want to have crowd control and a forklift on site and all the other stuff. And I don't want to have the worries of the panel twisting while I'm loading onto the roof. So I'm going to do 2 75-foot long panels. Okay, you put a fixed clip in the middle. One panel expands upslope, one panel expands downslope, because again, metal has to move. If panels are fixed at the high end or the ridge condition, free movement is required at the bottom. There's your joggle cleat for a floating eave. Pictured here are examples of a proper and improper eave detail. The correct detail is critical for long-term success of that roofing installation. Okay, a knee joint. Say you want to be modern and you want to turn a panel from a roof down a wall, right? Not a problem. However, it creates a point of fixation. So when you turn that panel and you cut the ribs to turn it down, 90 or 45, whatever you're doing, that creates a point of fixation. By definition, the panel now has to expand upslope. It's pinned at the eave. There's your knee joints or your kneecaps. This is what covers the vertical panel rib of a standing seam roofing panel that transitions onto the fascia. What's this one for? Oh, don't use it in snow. Okay, reach out to me if you want to use it in snowy climates. The freeze thaw effect can pop these things wide open. Snow shear can shear them straight off. So you have to be aware of how much thermal movement is going to occur. How far down the wall does this panel go? Number one, and where are you located? Number two is going to come into play. But this is an image of a failed kneecap in snow country. Okay, you're expanding up slope. How do you do the ridge or the high eave? Okay, high eave is on a shed roof. Your ridge condition is on your standard ridged structure. So the drag fasteners are not going to penetrate the substrate. They're going to penetrate that Z. The ridge cap is going to have a step in it. So the panel end support required for the secure connection to the Z closure of the panel. And the ridge is installed again with a step which acts as a hinge point to allow the cap to flex when the panels expand and contract. There's your floating eave. For longer roof runs, a fixed panel in the midpoint may be required. This again requires both the high and low side to float. Generally on long panel runs where the expansion contraction is so great that it makes it difficult to allow for it at one end, or the thermal movement exceeds the capacity of the clip, or on like a barrel roof, right? You pin it at the top and it goes down either side. So in these instances, the overlap between the hidden cleat and the turned under end of the panel at the eave may need to be increased to accommodate for thermal movement. It's important that these panels are not pinned in more than one location. If you fix it more than once, the panel can't move. It's going to pop and make horrendous noises when it gets heated up. If you have an outdoor patio cover that's even aluminum, you may have heard that. It'll go boom when it gets hot and the metal moves. If you're on the inside of a metal building, it's going to sound like a bomb's going off, and it's going to oil can that panel to no end. It needs to be able to thermally cycle. So stagger your panel laps. Again, there are some exceptions to this rule where you have batten panels like a T-seam or a bulb seam, but generally speaking, the cost of the spreader bar, the crane rental, the on-site crowd control, blocking of the area, no wind, are going to outweigh that. Fixed clips operate in the same principle as a fixed lap. They will both require the high and low ends of the panel to float. Fixed clips, again, are most commonly found on long length panel applications or for fixing the apex of a barrel roof. This is what a fixed clip looks like before it's seamed. Fixed in the middle, floating on the top, right? Expand upslope and downslope. Notice the lap. Oh, and this is something else. Check this out in the middle here, if you can see my pointer. That's a swedge mark. So when you lap a panel, again, they're not exposed fasteners, so you can't nest them, right? A 16-inch panel can't fit inside a 16-inch panel. It's the same width. So you have to swedge it. You take a tool, and it puts little ripples in that metal and makes it just skinny enough to fit inside the other panel. So that's something cool. All right, barrel roofs. Radius applications require the apex to be fixed or pinned. Panels cannot fully expand or contract around the radius due to the curve. So if a panel floats around the radius without a point of fixity at the apex, oil canning or a deflected appearance in the panels can take place. Fixed in the middle, floating everywhere else. Okay, what's this one? Varying panel width and thermal movement should also be considered when dealing with full-length roof panels at the gable ends of the building. In most cases, the installers will not be able to utilize a full panel width at these ends of the building. So this detail allows for the cutting of the panel to the necessary width that's been field verified and bending the panel edge up inch and a half or 2 inches, whatever your panel height is. Panel turn up is to protect against infiltration of wind-driven particulate. Once the panel's been turned up, the panel edge is inserted into a receiver trim and secured against wind uplift. This detail also allows for free, unrestricted thermal movement of the panel within that receiver trim. Drag load. Panels must be pinned. They must be pinned to allow the panel to move freely under thermal load, thermal cycling, and resist the drag load caused by the weight of the panel, live loads, and snow loads. So the intensity of the drag load is a function of slope, length, and some other loads involved. So snow and ice imparts a live load on metal roofs. Consequently, installations in cold environments, you have to pay close attention to. Reach out to me for assistance with that. Metal roofs are often the choice in cold climates. Take into consideration ice dams and so on. Cold roof systems that keep roof temperature near the same temperature as outside air may be the best for preventing the ice dam formation when properly installed and ventilated, of course. But generally speaking, in heavy snowfall areas, you want to design a steep pitch to allow for snow runoff. Also, self-adhered underlayment is also a huge consideration of that. Ice melt systems can be incorporated to reduce ice dam formation, not remedied by design, especially in areas more susceptible to buildup. Reach out to me on that as well. I have a whole bunch of information on that. Make sure that you engineer the roof for the expected site-specific loads. So without mentioning trade names again, reach out to me on this. Those same clamps that you can use for PV, you can also use to mount signage and conduit and snow retention and catwalks. Wide valleys. In areas where snow or rain is considerable, make your valley wider. Okay, pipe boot. I'm going to spend a little bit of time on this because this is often done incorrectly, okay? A pipe boot detail is often used for roof penetrations, right? Pipes penetrate the roof for various reasons, whether it's a ventilation, exhaust from the rooms below. Ideally, pipe penetration should be located in the middle of the roof panel or centered on the rib. When centered in the roof pan, the edge of the pipe boot, you want 3 inches, okay? I say stick a hand next to it, and if it's wider than your hand, it's too close. From the panel ribs. Otherwise, it doesn't allow for adequate water flow. So for this condition, or when a pipe lands too close to a rib or on the panel rib, you want to use a cut rib detail. But first, this is one of the only slides I'm actually going to read, okay? Care should be taken when installing the pipe boot. Follow manufacturer's recommendations. However, keep in mind, the pipe boot is attached to the panel only and not fixed to the roof substrate. If you fix the boot to the substrate, it will also fix the panel and it won't allow for thermal movement. So the pipe boot provides waterproofing for the penetration as well as the longitudinal panel movement. Okay, so if the pipe is in the middle of that pipe penetration and it gets hot and the roof expands down slope, it might not be in the middle towards the end of the day. It might scrunch up towards the top of that, right? So the hole in the panel has to be large enough to provide adequate room for the panel and the pipe to move within it, but small enough for that pipe boot to fasten to. And keep in mind, when you have exhaust from like generators or plumbing that rattles, right? That pipe's going to move and vibrate. So the hole's got to be big enough, but small enough. Don't fix the pipe boot to the substrate. It has to be able to move with the panel. So these pipe boots provide a lot of different, they operate in many different capacities for these pipe penetrations. So where it's on or near a seam, a cut rib home plate detail should be used when it's near a vertical rib, right? To help prevent corrosion, the ribs should be cut with a shear, never a blade or a torch. That's also part of installing a roof. So, incorrect, correct, right? That's right in the middle of a seam. That is bad form. Curves. Whenever the penetration is large or multiple, use a curve. If it goes a panel width and a half, you might want to use a curve. If it goes 2 panel widths, use a curve. So curbs are utilized from everything from skylights, solar tubes, HVAC, ventilators, anything large you want to put on a curb, put on a curb. It allows for large equipment or collections of equipment, i.e. if you have 4 pipe penetrations side by side, use a curb. It'll allow them to be installed and allow the panels to expand and contract around them. And we've reached the end. Are we on time? Oh man, 1 hour dead on almost. Good job.
Yeah,
Okay.
you did great. We have time for a couple of questions, and we've got a bunch of them.
All right.
So let me hold on a second here. Let me go back, and we've got a couple of questions about coatings, but I'm going to come back to those in a second. When you just mentioned roof curbs, and when you put up accessories like roof curbs and walkways and systems, walkway systems and that sort of thing, who's responsible for coordinating the roof system and those accessories and making sure everything works correctly?
Okay. I'm going to preface this by answering, because I have a feeling that this question is going to come up, is fall protection. I would stay away from any roof mounted fall protection, regardless if a manufacturer of a clamp or clip says that it's okay. Any fall protection, I'm going to preface this discussion, any fall protection should be mounted directly to a structural beam or member of that building. Use a pipe penetration with something coming up, with your davit tie off or your D-ring or whatever. Fall protection should not be mounted to the roof, okay? If the clip can withstand it, that's not saying that the clips that hold the roof down can withstand someone falling off, because a 200-pound adult falling off with a pressure washer off a roof is going to, the forces there are insane. Okay. That being said, that caveat being said, anything that's mounted to those clamps, you follow the instructions of the clamp manufacturer. So if the clamp has to be torqued to, I don't know, 200 foot-pounds, right? It should be torqued to that value exactly. It is not the responsibility of the roofing manufacturer, not just for my company, but from any company out there. They're going to say, you can use these clamps, we've been tested with them, but any damage caused by them or any equipment that's mounted to them, any equipment mounted to them is not going to be covered under warranty. So the answer is twofold. Number one, the manufacturer of the clip follow to the T. They're responsible for what values they're to be torqued to for your specific application. And number two, whatever trade follows and is attached to those, i.e. PV or signage or whatever, they are responsible for that secondary connection. So there's 3 parties at play here: the roof manufacturer, where their liability ends at the clamp; the clamps manufacturer, where their liability typically ends at the clamp if it's installed correctly; and the third party trade. I know it's a lot, but that's how it's played.
Let's talk a little bit about oil canning and how you can avoid it in exposed fastener or standing seam metal roof panels. You addressed it a little bit, but any particular techniques?
Okay, so oil canning, from, again, any manufacturer is going to have this language. Oil canning is an inherent characteristic of all metal. Proper steps should be taken to mitigate and whatever else, right? Okay, so the main thing here is number one, panel profile. If you have a flat pan, it's going to tend to oil can more than a profiled pan or profiled metal. Number two, gauge. Are you 26 gauge? Are you 20 gauge? Because the 22 gauge panel, which is my absolute favorite go-to for wall cladding, 22 gauge panels are substantially more robust and resist oil canning as compared to like a 26 gauge panel. Okay, so profile and gauge, number one. Number two. Number three is going to be handling and shipment. So say, for example, you have a 60-foot long roofing panel with a flat pan, and the manufacturer has done everything within their power to manufacture and load it, and it leaves the factory, right? Well, there's quote unquote two types of oil canning as well. The actual definition of oil canning is a repetitive, measurable characteristic as a result from the roll forming process. But in common nomenclature, oil canning is referred to anything that looks wonky when my metal is installed, right? let's be honest. It's why is it wrinkled, right? So if it's shipped and it's not protected adequately, if it's unloaded roughly, if the panel gets tweaked, when it's being loaded onto the roof, it's turned a little bit, you can put a microscopic little bend in that again, think of a piece of paper. If it's flat and you push it together, it'll bend in different places. But if it has any line whatsoever or any predefined point of flexation, it's going to flex there. It can cause oil canning. So get the thickest gauge you can. Oh, also color comes into play, right? Because darker colors are going to absorb more than lighter colors, which reflect more. Think of a white shirt on a boat versus a black shirt on a boat, right? Which one would you wear to stay cool? So all those factors come into play in the common nomenclature term of oil canning. To mitigate all of those, the best things you can do are, number one, have a profile, whether it's striations or pencil ribs on standing seam or a cladded profile on a wall. Number two, make sure you have a higher end gauge, like a 22 or a 24. And number three, have a good installer, have a good contractor. And all that together is going to help, of course, besides the whole thermal movement discussion, right? Metal has to be able to move. So hopefully that answers it.
Thanks. Let's take one more question. And I did want to say, we do have a lot of folks are asking questions about coatings and paint and its performance and how you handle scratches and that sort of stuff. Jeffrey could go into all of that, but I'm going to encourage people. We're doing a webinar on April 21st about understanding pre-painted metal. And it'll be all of those coating questions will be dealt with in depth in that webinar. So look forward to that. But Jeffrey, one more question here about these externally mounted clips. Richard's asking, it would seem that the clamps would only need to avoid the, can they restrict the movement of panels, the clips? All you have, and Richard says it would seem they only need to avoid the clips beneath if the roof floats properly on the clips. Is that correct?
So I see where you're going with that, and that's a pretty in-depth question, Richard. So yes, if it was directly on, if it was an unlimited thermal moving roof system, and you happen to clamp it directly on a clip that is below, and you torqued it past the recommended torque spec, yes, it could compress it to the point where it wouldn't move freely around that clip. However, if you torque to the correct specs, it's not really going to happen. It clamps on the outside, and it doesn't go through at all, doesn't put holes in the standing seam. And typically speaking, a 24, 22 gauge panel is more than robust enough to resist the compression, to clamp down on an internal clip that hard. Going to another question that you said about scratching is, if you were ever to remove said clamps and you had scratches below it, you can coat or paint Kynar with a Kynar-based touch-up paint that's provided from the manufacturer of your panel. So the clips, the clamps, not clips, excuse me, the clamps are removable and reusable.
Jeffrey, thanks so much for a great presentation. The comments here from folks are just fabulous. The depth of knowledge is great, and a lot of the questions we've gotten here are kind of very specific about particular projects that people are working on. So I'm going to encourage those folks. Jeffrey's email address is there on the screen, and follow up with him. And if you have specific questions, he can help work you through that. If you want more information, you can go to aepspan.com. And again, a reminder that AIA credits and certificates are going to be handled automatically. Please allow 7 days for those to process. Tomorrow's email is going to have more information and links to download the slides, as well as to listen to the presentation again. And I just mentioned it, we're going to do another webinar on April 21st on understanding pre-painted metal. It's presented by Steelscape, and you can always find the latest information about our webinar series at metalarchitecture.com/2022-events. Jeffrey, thank you so much. Great presentation, and thank you all joining us today. Appreciate it. Everybody have a good day. Take care.
Thank you. Take care.